This is section 5-1. We are on page 225, and this time we're talking about scientific notation. Okay, so this formula usually uses standard notation. We just write out the numbers completely. But we can also write it in scientific notation, because sometimes our numbers are really, really big or really, really small. And it's easier to be able to understand the number if we write it in scientific notation. So the form of scientific notation is A times 10 to the nth power, where A has to be greater than or equal to 1 and less than 10. And our n, so our exponent on our 10, has to be an integer. So let's pick a number and look at it in scientific notation. So we have the number 6,380,000. So let's look at this. We have 638,000. So the way we would write this is we would write this as 6.38. So we take our first number, we put a decimal point, and then we have our 3 and our 8. And the rest of what we have are zeros. Because this 6.38, that falls in the rule that A has to be greater than or equal to 1 and less than 10. And we want to make sure that we have all of our numbers in there after the decimal point too, so we know exactly what number we're using. So we don't want to just put 6, because that leaves out the 380,000. So now obviously the number is not 6.38, so we need to times this. We do times 10, but 6.38 times 10 to the what gives us 6,380,000. So we need to look at the decimals. Okay, how many would we have to move it over to the left to get 6.38? So we'd have 1, 2, 3, 4, 5, 6. From the right, counting all the zeros, we'd have to move it over 10 spaces. So that's 10. So it's 6.38 times 10 to the 6th power. And that's it in scientific notation. Okay, so let's try another one. 57,420,000. Yeah, that's enough zeros. Okay, so now let's put this into our formula where A is greater than or equal to 1, less than 10. So that would be 5.742. So we have all of our numbers in there. Now let's look at the times 10, the powers, what we need to put on our 10. So starting from the right, let's count our zeros over. So we have 1, 2, 3, 4, 5, 6, 7 times 10 to the 7th. The way I got that was from the right, I moved the decimal point over first to the 1 spot, and then to the tens, hundreds, thousands, 10,000s, 100,000s, and so on. And so it's 5.742 times 10 to the 7th power. Hey, now what if we have a really, really small number? Let's say 0.00047. Okay, so when we write this in scientific notation, again, A has to be greater than or equal to 1, less than 10. So if we have 0.000047, we want to move the decimal point all the way to the right. We want to move it 1, 2, 3, 4, 5. So the decimal point is in between the 4 and the 7, 4.7, because that fits the rules. But what power of 10 do we need to multiply it by to get there? Because 4.7 is much bigger than 0.000047. So that we have to move it over 1, 2, 3, 4, 5. But we're moving it to the right, so we're making it bigger, so which means we have a negative exponent. So that's 10 to the negative 5th power. So 4.7 times 10 to the negative 5th power. And in this instance, we want to write that as a negative exponent. So 4.7 times 10 to the negative fifth is the scientific notation for 0.000047. Okay, so how do we multiply numbers in scientific notation together? So if we have, open parentheses, 4 times 10 to the fifth power times, close parentheses, open paren, 2 times 10 to the seventh power, what we need to do is using the associative commutative properties, we multiply our first number, our A term, and then we multiply together our powers. So we can rewrite this as 4 times 2 times 10 to the fifth times 10 to the seventh. So our first monomial, we have 4 times 2, which is 8. And now we have times, we have 10 to the fifth times 10 to the seventh. We know if we have a same base, we add our exponents. So we have 8 times 10 to the 5 plus 7, which equals 8 times 10 to the 12th power. And let's look at dividing scientific numbers in scientific notation. So if we have 8 times 10 to the 12th power, all divided by 2 times 10 to the 9th power, we do the same thing. We basically divide our coefficient, our constants, 8 divided by 2, which gives us 4. And now we have times 10 to the 12th on the numerator and times 10 to the 9th on the denominator. So you have 10 times 10 to the 12th minus 9. So now we have 4 times 10 raised to the 12th minus 9 is 3. So that's 10 to the third power. Let's do another example. So if we have something like, sorry, cat on the keyboard. If we have something like 6 times 10 to the 13th power all over 3 times 10 to the 4th power, again, we first divide our constants. 6 divided by 3 is 2 times, and then we look at our powers. So 10 to the 13th divided by 10 to the 4th, then that would give us 10 to the 13th minus 4, or 2 times 10 to the 9th power.